Today I am going to give a talk on tides. The tides I have divided into number of topics or number of modules, like 7 modules. Like the first module is the introduction, followed by forces producing tides, types of tides, origin of tides, then tide table prediction, then significance of tides, finally conclusions. So, let us start from the introduction. It is the tides refer to the regular rise and fall of water level in the world's oceans resulting from the gravitational attraction that is exerted upon the earth by the sun and the moon. They are the longest wave known. Like other waves, they have a crest and a trough. The movement of the crest and the trough brings about the tidal phenomena. Tides are universal and everyday phenomena. Generally, 2 high tides and 2 low tides are observed daily. That means, per tidal day, that is 24 hours 50 minutes, corresponding to the time between successive phases of moon over any point on earth. Then the second is the forces producing the tides. So, one is the gravitational force. So, that is one of the important force which you can see. The gravitational force is the force of attraction between the masses and is directly proportional to the product of the masses being considered and is inversely proportional to the square of the distance between them. Gravitational force is mathematically expressed as F is equal to G into m1 into m2 by r square, and where J is the universal gravitational constant, m1 and m2 is the masses, then r is the distance between m1 and m2. Centrifugal force is an apparent center fleeing force felt by objects experiencing uniform circular motion. It is the result of internal resistance to centripetal acceleration. This force is felt equally on all points of the earth, directed away from the moon along a line that parallels a hypothetical line joining the center of the earth and the moon. Coriolis effects or Coriolis force. Coriolis force is an apparent force caused by the rotation of the earth, which is responsible for the deflection of surface currents towards the right in the northern hemisphere and to the left in the southern hemisphere. The Coriolis force plays an important role in the deformation of rotating standing wave, that is Kelvin waves, in basins. Origin of tides. The origin of tides can be explained in terms of 2 approaches. This method is studied by the equilibrium tidal theory. The second include the study of tides as they occur in nature, modified by the land masses, geometry of the ocean basins and the earth's rotation. So, this is the dynamic tidal analysis. So, let us discuss one by one. The equilibrium tidal theory. The equilibrium tidal theory of Newton's is based on the assumption that the earth is covered by a uniform layer of water. This was sought to simplify the relationship between the oceans and the tide rising bodies, the moon and the sun. This results from the differential gravitational attractions of the moon and the sun over the surface of the earth. The moon is nearer to the earth and therefore, its effects is felt more than the sun. The moon therefore pulls harder on the surface nearest to it, and the force of gravity decreases with increased distance. The side nearest to the moon is attracted with more force than the earth's center So, the water there is pulled away from the earth into the tidal bulge. The earth center is in turn is attracted with more force than the side farthest away. So, the earth is pulled away from the water on the distant side, which forms the second tidal bulge. These bulges are held by the difference in moon's gravitational pull on the four sides of the earth, while the solid earth rotates daily beneath them, giving 2 high tides for each 24 hours rotation. The depression between the bulges are low tides. The sun also contributes to tides, although it is less effective as the moon in raising tides. The sun has 200 times greater gravitational force than the moon, but does not produce tides as high as 200 meters or at least as great as the moon. This is because the earth's diameter, which is about 12,740 kilometers, is a tiny difference compared to 150 million kilometers distance of the sun and the sun's pull on the farthest side. Therefore, though the sun's effect is great, its pull is nearly equal on each side of the earth, producing only a small tidal bulges. Although the gravitational pull by the moon are much less, the difference between the lunar pull on the near and far sides of the earth is more appreciable. For this reason, the moon easily out-tides the sun and forms a greater than the sun. However, this theory was modified later on, for the earth as a whole just balances the centrifugal force produced by the rotation of the earth about the center of mass of the earth moon system. The gravitational force pulls for the earth as a whole just balances the centrifugal force produced by the rotation of the earth about the center of mass of the earth moon system. The gravitational force pulls the masses together. On the other hand, the centrifugal force acting in opposite direction keeps them apart. The earth and the moon therefore act as twin planets revolving about a common center, which in turn moves around the sun. If the earth and moon were of the same size, the center of mass is located at a point on earth 4,700 kilometers from the center of the earth. So, the diagram gives a clear idea. The centrifugal force at any point on earth's surface is the same for the unit mass, but the gravitational force varies according to the distance of the unit mass from the moon. Thus, there is a net force directed towards the moon at the point on the earth's surface closest to the moon, and a net force directed away from the moon. The tidal force experienced at any point on earth is therefore the vector sum of gravitational force and centrifugal force. On the side nearest to the moon, the attraction of the moon exceeds the centrifugal force, so that the water is attracted towards the moon. On the opposite side of the earth, the centrifugal forces overbalance. On the side nearest to the moon, the attraction of the moon exceeds the centrifugal force, so that the water is attracted towards the moon. On the opposite side of the earth, the centrifugal force overbalance the attraction of the moon, so that even there is a force acts on the water, dredging it away from the earth. The merits of this theory: it could explain the periodicity of tides, it gives us an understanding of the distribution of wave level changes and the rising forces, then the demerits earth having uniform layer and depth of water is not justified. It does not explain the variety of tidal range and tidal period appearing at different locations on the same day. The bottom of configuration and the continents that obstruct the movement of tides have not been considered. So, the second theory, the dynamic tidal analysis. This theory consists the configuration of ocean basins, frictional force, Coriolis force, convergence and resonance and many other variables. Although the predicted tide rising forces are the same, the behavior of the tidal wave on earth varies considerably from that on a smooth covered model used to explain the equilibrium theory, because the continents separate the oceans from each other and that tidal wave is discontinuous. Only in the southern ocean and Antarctica, where continents do not stretch far into the ocean, the tide wave has a long wavelength as compared to the depth of the ocean. Therefore, it behaves like a shallow water wave with its speed controlled by depth of water. The tidal wave also gets reflected from the edge of the continents. It gets refracted by the change in water depth and diffracted as it passes through gaps between continents. The predicted equilibrium tides do not accurately correspond to observed tides, because the average depth of the ocean is about 4 kilometers, and according to calculations c square is equal to g into d. The ocean depth should be around 4,40,000 kilometers in order to have an equilibrium tide, which cannot be compared to an average depth of 4 kilometers. The rotation of the earth further modifies the scheme of oscillations. The Coriolis force deflect the tidal wave from their original path. The time of water flow high water side to low water side of a basin is long, and it gives sufficient time for the Coriolis effect to work. The Coriolis force deflects the tidal waves to the right in northern hemisphere and to the left in the southern hemisphere, and this will produce a gyratory motion which the wave will rotate over a central point known as ampidromic point. The ampidromic point is at once co-tidal with high and low waters, which is satisfied by 0 tidal motion. Then tidal motion generally lessens moving away from continental coast, so that crossing the co-tidal lines or contours of the constant amplitude, that is half of the distance between high and low water, which decrease to 0 at the ampidromic point. The tidal crest radiates away or out from these points. The lines connecting tides of same tidal range are called co-range lines. So, now let us coming to what are the different types of tides. So, we have daily tides, that is we call it as a diurnal tide. So, the behavior of tides is different in different regions. In some coastal areas there is a regular pattern of one high tide and one low tide each day. This type of tides is called diurnal tide. The tidal period is 24 hours 50 minutes. So, the diagram clearly indicates the picture, wave character of a typical diurnal tide. Then the second type is semi-diurnal tide. In some coastal region there is a high water low water sequences that is repeated twice in a day. Such tides are called semi-diurnal tides. So, wave characters of a typical semi-diurnal tide. Then coming to the mixed tide, when there is a difference in the level of too high water and too low water in a semi-diurnal tide, such tides are termed as mixed tides. So, the diagram wave characteristics of a typical mixed tide. Then monthly variation of the tides. Spring tide, this is during the 29 and off day, it takes the moon to orbit the earth. The sun, the earth and the moon move in and out of phases with each other. During the period of new moon, the moon and the sun are lined up on the same side of the earth, that is synge, so that high tides or bulges produced independently of each other coincides. Since the water level is the result of adding of the two waveforms together, tides of maximum height and greatest range between high water and low water are produced. These are spring tides. Neap tide. In about a week, the moon in its first quarter by moving its orbit until it is located at right angles to the line of center of the earth and the sun. Therefore, the crest or bulge due to the moon tide is at right angles to the side wave created by the sun. The result is that the crest and the trough tend to cancel each other and the range between high water and low water is small. These are low amplitude neap tides. Spring tides give rise to extreme tidal range, while neaps results in less extreme tidal conditions. There are 7-day interval between spring tides and neap tides. The changing distance separating moon and earth also affects tide heights. When the moon is closest at perigee, the range increases, and when it is at apogee, the range decreases. Every 7.5 lunations, that is full cycle from full moon to new to full perigee, coincides with other new or full moon, causing perigean spring tides with largest tidal range. So, the diagram clearly indicates the perigee and the neap tides and other things. This is characteristic of wave, spring and neap tides. Then let us come into the tide table predictions. The heights of tides are determined by a complex combination of factors rotating to the position of the earth, sun and moon, real time to their rotation and revolution. The position of the sun, moon and earth keeps on changing. For example, when the moon and the sun align with earth, high tides occur, while the perpendicular alignment of the sun and moon relative to earth will reduce the height of the tides. Although tidal characteristics are largely determined by these regularly occurring and predictable astronomical forces, constructing tide table is not an exact science. Among other factors such as existing ocean currents and winds, depending on their direction, can either negate or accentuate a tide's pull, while topography both above and below the ocean surface can also tides down, speed them up and even rise or lower their height. The most accurate tidal predictions usually exist for places located on the coast because they are less affected by winds and other meteorological events. Areas in bay or shallow are more affected by alternate factors. In the United States, the Center of Operational Oceanographic Products and Services of Co-ops is the official source of predictions for approximately 3,000 locations around the country, also makes predictions for other countries and territories. Since predictions are also based on actual tide movements in many areas over an extended period. For these observations, the National Oceanic Survey tides stations that have equipment to make the following measurements every 6 minutes: tide levels, wind speed and direction, and water current and speed and directions, air and water temperatures, barometric pressure. The collected data is relayed to the center every hour and is immediately available on the internet from the links. Stations that provide these full daily predictions are called reference stations. The rest of the stations are subordinate stations which obtain their predictions by applying a specific formula is derived by observing how tides of the two stations related to one another in the past. Significance of the tides. Tides are responsible for moving large amount of sediments perpendicular to the coast. Tidal range governs the width of littoral zones. The periodic rise and fall of tides varies the distribution of wave energy along the beach profile. Tides influence the distribution and morphology of the tidal flats, coastal deltas, barrier islands, splits, etc. The tides influence the salt and freshwater mixing in estuaries. Tides play an important role in the mixing of ocean water. In the world of commerce, tidal flows are important for navigation and fishing. The tidal force can be used as a source for generating electricity. For example, France and Japan have power stations which convert the tidal energy into electricity. Tides help to clean coastal areas. The receding tides carry away most of the rubbish of the coastal town thrown on the sea coast. Tidal movement helps in studying the intertidal ecology. This refers to the study of intertidal ecosystem as organisms thrive in the intertidal slopes created by the different level of tidal ranges. The intertidal slopes are divided into zones along with the characteristic species of organisms that thrive in each zone. Organisms are covered by water during high tide but are exposed at extreme low tides. Sea water keeps on moving to tides and does not freeze even in highest latitudes. This is the reason why most of the British ports remain ice free due to tides. Some common misapplications of tides includes as such: tsunamis caused by earthquakes are sometimes called tidal waves, but they are not. Their name is simply given by their resemblance to tide. Other phenomena unrelated to tide but using the word tide or nip tide, storm tide, hurricane tide and real tide. The term red tide originated when observers did not have any technology to look closer, much closer at what was tinting the water red. They are nothing but discoloration of coastal water by the presence of the cline flagellatas, which are the type of florist or single creatures that have a characteristic of both plant and animal. They may be usually colorless or of white, but here and some varieties of pink, blue, etc. They are bioluminescent and impart a blue color to the water at night due to the chemical reactions taking place in the body. They are also caused by algae bloom, which is due to the influx of nutrients into the water. Conclusion: Tides are rise and fall of the water in the ocean due to forces. The moon has more impact on tides that the sun, moon and earth keeps on changing with time. The highest tidal range occurs at Bay of Fundy, that is Nova Scotia, 17 meters, that is 56 feet. The tides can be determined using astronomical data in addition with the relative measurements of meteorological and ocean topography over an extended period of time. Tides are significant forces and they hold prospect for generating power for domestic purposes and industrial use. Tides are also important in studying ecological relations of organisms living in intertidal zones.